Hello, everybody. Welcome to the EEE185 project with Muiz Khan, Corey Dunham, and Megan Rodriguez. Our project is on cognitive radio. Here, you can see our table of contents. We will be talking about the abstract. We will lead into the introduction. We have a problem statement, our proposed approach, a literature survey, our conclusion, and finally, the references that we used. So here is an abstract of what cognitive radio is. Cognitive radio technology allows a group of potential users to identify and access available spectrum resources as long as the interference to the users that the band has already been licensed to is kept below a certain level. This research area is at a very young age because various challenges have to be addressed and solved. This report will present an overview of some of the research issues for cognitive radio networks. We will present some research and development in cognitive radio networks with three main focuses: information theoretic aspects, spectrum sensing, and link adaptation. Here's our introduction. Cognitive radio is a form of wireless communication where a transceiver can detect which communication channels are being used and which are not. Transceiver going into the empty channels, avoiding the occupied ones. There are four main blocks in cognitive radio: spectrum sensing, spectrum management, spectrum sharing, and spectrum mobility.
Now we have the problem statement. So the first one, which is theoretic analysis of CR channels. The dynamic spectrum allocation is a common issue in cognitive radio where CR users operate in licensed bands with legacy users. This is due to regulatory entities allowing for secondary use of underutilized spectrum. Next, we have spectrum sensing. Cognitive radio systems face the challenge of identifying primary users across various spectrums with different modulation schemes, data rates, and transmission powers, which can be difficult due to variable propagation losses. Spectrum plays a crucial role in this identification process due to regulatory entities allowing for secondary use of underutilized spectrum. Next, we have OFDM-based cognitive radio systems. Spectrum sensing in cognitive radio systems, mutual interference between primary and secondary users can occur due to non-orthogonal signals in the unused band used by secondary users in an OFDM fashion. The interference level is dependent on the location of subcarriers relative to primary users' spectrum and transmitting power. Next, we have the proposed approach. So the first part of this is a proposed approach to theoretic analysis of CR channels. Two approaches to address interference in cognitive radio are interference avoidance and interference mitigation. Frequency hopping and frequency coding are two methods used for interference avoidance, with the former using causal side information and the latter using non-causal side information. Next, we have the proposed approach for spectrum sensing. One approach, or one of the main approaches to address interference in cognitive radio is to use highly sensitive and quick scanning sensing devices with cooperative diversity and decision statistics in combination with methods being explored. Cognitive radio and WSN or Internet of Things technologies can be utilized to enable spectrum sharing and aid in PU channel monitoring. Last but not least, the proposed approach to the OFDM-based cognitive radio systems. An approach to mitigate interference in cognitive radio is subcarrier nulling. This involves nulling the subcarriers adjacent to the primary user band to reduce interference. But this creates a trade-off between achieving a higher transmission rate and losing degrees of freedom. Last but not least, further studies have been conducted to evaluate the effects of subcarrier nulling on various schemes.
Next, this is going to be our literature survey. Wireless communication is getting more popular, so the need for cognitive radio increases as well. This research paper goes over multiple techniques used in spectrum sensing and why they are efficient or inefficient. The two main techniques used in spectrum sensing are energy detection and cyclostationary feature detection. The research paper goes over why energy detection is sometimes inefficient and why cyclostationary is in some ways the more efficient technique. The energy detection is inefficient because the threshold used for detecting energy in a certain channel has to be really low in order to sense something, and sometimes it has to be below the floor. This can make it fail. On the other hand, cyclostationary feature detection is much more efficient. Overall, as these techniques have failed at times, there are ways to make them more efficient, as the research paper discussed the reasons why they fail. To conclude, cognitive radio is a technology that enables the dynamic usage of underutilized spectrum to secondary users. CR users can observe the local radio scene and dynamically adapt to it. Spectrum sensing is a key challenge in cognitive radio, which can be performed through energy detection or cyclostationary feature detection. Orthogonal frequency division multiplexing is a widely used technology in CR systems, as it can provide an efficient revitalization of unused spectrum among secondary users. However, OFDM-based CR systems introduce mutual interference between primary and secondary users due to the non-orthogonality of transmitted signals. Optimal power and bit loading algorithms have been proposed to maximize the downlink transmission capacity of CR users while keeping the interference induced to primary users below a specific threshold. Two suboptimal schemes, interference avoidance and interference mitigation, have also been proposed.
Here are our references that we use for our paper. Thank you very much. We hope you enjoy the paper, and that is it.